A 420-foot crane boom collapsed at the LyondellBasell Houston refinery in Pasadena, Texas. 4 workers were killed. 6 more were injured. OSHA engineers went to the site within 12 days. What they found was not a freak accident. It was an operation run at an angle beyond the crane's own safe limit, while a known mechanical fault had already triggered that morning. This video is the full breakdown of what OSHA investigators documented, and what every crane operator, rigging supervisor, and site manager needs to know. Let's establish what this video is based on. The source is the official OSHA Engineering Investigation Report, authored by Dr. Scott Ginn, P.E., from the OSHA Office of Engineering Services, Directorate of Construction, dated January 13, 2009. This investigation covered site inspection on July 30th and 31st, 2008. It includes witness statements, operator manuals, video analysis, and a full structural engineering analysis of the crane. Fatality data context. According to the Bureau of Labor Statistics, construction and extraction workers recorded 1,032 fatalities in 2024. Crane-related incidents are among the highest severity events in the industry. When they occur, multiple workers are at risk simultaneously. The crane involved was the Versa TC 36000, one of the largest mobile cranes in the world at the time, designed with a 1 million pound lifting capacity. Deep South Crane and Rigging Company, known as DSC, assembled and operated it at the site. Here is what happened, step by step. The Versa TC 36000 was assembled at the LyondellBasell Houston refinery over approximately 4 weeks before the incident date. The configuration: a 420-foot boom, a 240-foot mast, and 836,000 pounds of main counterweight, already attached and in place. On the day of the incident, July 18, 2008, the crew was in the final stage of crane setup, attaching an additional 836,000 pounds of auxiliary counterweight. This would have given the crane a 1 million pound lifting capacity. 2 iron workers were in an aerial lift basket, the JLG lift, working to connect metal bars from the auxiliary counterweight tray to suspended pendants at the top of the mast. That was the task. That was where 4 people lost their lives. At approximately 9 o'clock in the morning, 4.5 hours before the collapse, the main winch stopped working. The main winch is the critical component that controls movement of both the mast and the boom together. It is not an auxiliary system. It is the primary control mechanism for the crane's 2 largest structural elements. The crane supervisor called the DSC main office in Baton Rouge, Louisiana. Over the telephone, technical staff walked the supervisor through testing the control panel and replacing the winch operation lever. The problem appeared to be resolved. Operations continued. OSHA investigators later confirmed this decision, to continue crane operations after a primary control system fault, was a critical factor in what followed. No additional mechanical inspection was carried out. No operational hold was called. The crew resumed work on the counterweight installation. To understand what caused the collapse, you need to understand the concept of overhaul. Overhaul is the point at which a crane boom passes its balance angle and begins to fall backward under its own weight. Every mobile crane has a documented overhaul limit in its operator's manual. For the TC 36000 in this configuration, the OSHA analysis determined that overhaul would occur at a boom radius of 114 feet, corresponding to a boom angle of 75 degrees. According to the OSHA investigation, video footage from the site shows the crane operating at a boom angle of approximately 79 to 80 degrees at the time of the collapse. That is 4 to 5 degrees beyond the overhaul limit. Once the boom passed 75 degrees, physics took over. The boom began to fall backward. The boom stops. The mechanical components designed to prevent this engaged and failed under the load. OSHA engineers calculated they were not designed to stop the boom in this configuration. At approximately 1:40 in the afternoon, the boom fell backward onto the mast, the spar, the assist crane, and the aerial lift basket where the 2 iron workers were working. The entire catastrophic collapse took only a few seconds. OSHA's engineering investigation reached the following documented conclusions. These are direct findings from the official report. Finding 1. DSC operated the crane at a boom angle of approximately 79 to 80 degrees. This was beyond the allowable overhaul angle of 75 degrees. The OSHA report states directly, and I quote the finding, that DSC, quote, operated the crane in an unsafe condition. Finding 2, the boom stops, which are required by ASTM B30.5, Section 5-1.9a, to resist the boom falling backward, were not designed by DSC to stop the boom from falling backward. This was a violation of the industry standard. Finding 3, the design also did not comply with SAEJ 220, Section 4.1, the industry standard governing boom stop performance. Despite this, the crane had passed its most recent certification tests in 2000 and 2003. Finding 4, the morning winch failure was a direct precursor to the collapse. The main winch controlling both the mast and the boom together had experienced a fault hours before the fatal incident occurred. The OSHA report concludes, the incident was caused by the failure of the boom stops, combined with operation of the crane beyond its documented safe angle. Every crane incident investigated by OSHA produces a report. Those reports are publicly available at osha.gov. They are not opinions. They are engineering analyses conducted by licensed professionals. From this case, there are 3 operational lessons that apply on every crane operation today. Lesson 1. Any primary control system fault, winch, hoist, limit switch, is a work stop event. It is not a call the office and keep going event. OSHA 29. CFR 1926.1412b requires that equipment which has had a repair or adjustment relating to safe operation, including a control system repair, must be inspected by a qualified person after completion, prior to returning to use. Lesson 2. Boom angle limits are not guidelines. They are engineering limits documented in the operator's manual. Operating beyond the rated overhaul angle, even briefly, places the entire load path in a configuration the boom stop system was not designed to manage. Lesson 3. Workers in aerial lifts in the crane's load path, or swing radius, must be removed from that zone before any crane movement occurs. In this case, 2 iron workers were in a JLG aerial lift directly in the collapse zone during active crane operations. 4 workers died, 6 were injured. The OSHA report exists. The lessons are documented. That is what this channel exists to make sure you know. Now, before you move on, we do the 3-step safety check. Every video on this channel ends here, because information without action is useless. Go through that list of hazards in your mind right now. Which of those exist at your site right now? Not which ones could exist. Which ones do exist today? Be honest, because the workers around you need you to be honest. For each hazard you identified, who owns the fix? In most jurisdictions, the employer or principal contractor is legally responsible for ensuring the site is safe. But supervisors have a duty to report, and workers have a right to refuse work they genuinely believe is unsafe. Know which category applies to you, and know what your rights are in your country. Do not wait for someone else to fix a hazard you can see right now. If you are a supervisor or safety officer, document the hazard today. Issue a corrective action. Set a deadline. Follow up. If you are a worker, report the hazard to your supervisor in writing. Even a text message creates a record. If the hazard is immediate and serious, stop work. If you get no response, in the USA, file a complaint at osha.gov. In the UK at hse.gov.uk. In Canada at your provincial safety authority. In Australia at your state workplace safety authority. Every one of those reporting systems allows anonymous reporting. Use them. This is Construction Safety Decoded. Every video on this channel is built on official investigations, government data, and documented cases. No speculation, no invented numbers, no sensationalism. If this breakdown is useful to you, subscribe. A new case analysis is published every 2 days. The OSHA investigation report for this incident is publicly available at osha.gov. The link is in the description. Stay informed, stay safe.